Do we have any notes we have to download today?
Yeah, there are.
What's the function operations PDF?
Yep, yep.
Okay.
All right, everyone. Happy Friday. Let's go and get started on our do now. So the first question is, what's your favorite dessert? So go and write your answer in the chat. And the second question is, how do you check for an extraneous solution? In other words, how do you know what solutions work and what solutions don't work when you finish solving a radical equation? 3 minutes on the clock. Ooh, got 2 brownies. And then if your video is not turned on, aka everyone, go ahead and take a moment to turn it on. Thank you, Ethan. Thank you, Hannah. Thank you, Liana. Two more minutes to answer the question.
I'm not trying to see. I'm not trying to let you guys see my background. That's why I have my camera off. Gee, I'm trying to print. Nothing. It's just might be a little messy. Actually, my mom just cleaned, but still.
One more minute to get your answers in the chat. All right, let's go ahead and answer the do now. How do you check for an extraneous solution? So once you solve a radical equation, how do you check your answers? What do you have for me, Hannah?
You plug it in.
And then when you plug it in, what are you looking for? Hannah, back up.
I don't know.
Like, how can I, once I plug it in, how do I know if it works or if it doesn't work?
Oh, it'll be equal.
Yeah, so it has to be a true statement. So it's a true statement like 5 equals 5, and that's correct. But if it's something like 2 equals 5, that's false. So that's an extraneous solution. Good job. Thank you, Hannah. All right, let's go ahead and do good things. So today's good things are coming from Layla, Liana, and Sandra. So Layla, go ahead and get us started. What's your good thing?
I don't think I got one.
Just what's the best thing of today?
This the last class.
That's great. Yep. And then after that, it's the weekend. So that's a great thing. Thanks for sharing. Liana, what's your good thing?
I'm gonna hang with my friends today after work.
Awesome. That's exciting. Thanks for sharing. And then Sandra, what's your good thing?
Tomorrow I am leaving to Kings Island
Oh, fun. Are you going for just the day or are you going for the whole weekend?
for the whole weekend.
Awesome. That's so fun. Have a great time. My good thing is that it's Friday, and y'all know on Friday, that means it's Pizza Friday. So gonna be ordering myself a pizza. I'm gonna be eating that pizza, and it's gonna be great. If you have any suggestions,
Pizza every Friday?
what'd you say? Layla and then Karen.
Every Friday?
Do I eat pizza every Friday? Yeah, you betcha. Pizza Friday. Do you not like pizza, Layla?
I do not that much.
You're
You
missing
gotta
out.
try something else on Fridays. Try Yats Fridays or something.
Well, Yats Fridays. What if I do Yats Saturdays? That could be a thing.
That would work.
Yeah, I
You
should go to Yats
do.
often because it's literally like 2 blocks from my house. But maybe tomorrow, Ethan. You've inspired me. Karen, what were you gonna say?
I was gonna say, what kind of pizza do you order since you're vegetarian? You just eat like veggie pizza?
Great question. I have like a couple favorites. I usually go to Basbo, and there they have like they have one pizza that has like olives, pesto, sun-dried tomatoes, and feta cheese. I really like that one. They also have another one that has like goat cheese and tomatoes and eggplant. That one's really good. They've got this Mexican pizza that's really good. They've got there's like a classic margarita. I could keep going, and that's just at Basbo. But then I also like Greeks. I also like Puccini's. What else do I like? I like Boombas.
Both is like overly bougie. Like they doing the most with some pizza. It's like it's just order a cheese pizza. They doing way too much.
Ethan, I feel like we're not agreeing on our food choices. I think you just have to give it a try. I think you have to try one of their fancy pizzas, and maybe we'll change your mind.
I don't like their crust though. It's too thin.
I do agree. Their crust is a little too crispy. I like Greek's crust a lot. Like I feel like if they combine the toppings at Basbo with a Greek's crust, could be a game changer.
Nah, I'm gonna just go to Jets and get cheese pizza.
I do like Jets a lot too. Maybe I'll go to Jets today. Anyone else?
Here's the idea. We both agree on Jets.
Okay, good. I'm glad that we came to some sort of compromise and agreement. It would have really upset me otherwise. Any other thoughts on pizza before we move on to math? Cool. All right. Let us get started. Before we do the new stuff, are there any questions from the homework last night that I could go over? No, we're good to go. We're G to G on the homework. Cool. Also, I just remembered that your class is the class that I record for everyone else. So they're going to enjoy like a 5-minute conversation about pizza and they're going to be confused and it's going to be great. All right, now let's get started with the math. Today we're going to be talking about function operations. So operations in math refer to addition, subtraction, multiplication, and division. So we have already talked about how we can do operations with numbers and variables. Today we're going to extend that to equations. So how do we add, subtract, multiply, and divide equations? For the purposes of today, the equations are going to be in function notation, which means that they're going to be written as f of x or g of x. Same thing, it's just the way that you write out an equation. And this is the notation. So basically when they say f plus g of x, they're asking you to add the two equations. F minus g of x, they're asking you to subtract. fg of x, they're asking you to multiply the two equations, and f over g of x, they're asking you to divide both equations. So for example 1a, let f of x equal 3 square root of x and g of x equal negative 10 square root of x. Find f plus g of x and state the domain. Then evaluate the sum when x equals 4. So also I meant to tell you all, we're going to be using our graphing calculator today. So if you have your graphing calculator, take that out because we will be using it in just a moment. All right. This tells me I need to add my two functions together. So f plus g of x is equal to f of x, which is 3 square root of x, plus g of x, which is negative 10 square root of x. You don't need to write a plus a negative. We can just rewrite that as a minus. So 3 square root of x minus 10 square root of x. And then anytime we add or subtract radicals, we combine the coefficients. So 3 minus 10 is negative 7, and then keep the radical. So regardless of what radical you have, if it's a square root, if it's a cubed root, if it's a fourth root, keep the radical, just combine the coefficients. So f plus g of x is equal to negative 7 square root of x. Any questions on how we added those together? All right, the next thing we need to find is the domain. So remember, the domain tells you all of the possible x values for the graph. And that's why we'll need the graphing calculator, because we want to see what this looks like on a graph. So if you hit y equals on your graphing calculator, clear out anything that you might already have in there, and then type in this new equation. So negative 7, make sure you use the negative button and not the minus sign. Second function, x squared, and then x. Does anyone need help typing that into their graphing calculator? All right, and then we're gonna hit graph. So the graph button is right up here. And you'll notice my graph only takes up the right side. So there's nothing on the left side. So when you're looking at domain, you're just checking how far to the left does my graph go and how far to the right it goes. And you'll notice that there's nothing on the left side. It stops at 0. All my x values, all my points are on the right side. So that means you can only have positive x values. So the way we write that in mathematical terms is x is greater than or equal to 0, because it has to be bigger or equal to 0. You can't have any negative numbers in your domain. Any questions about domain? All right, the last part, evaluate the sum when x equals 4. So they basically want you to plug in 4 everywhere you see an x in your equation. So the way we write this out is f plus g, but instead of x, you're going to plug in a 4. So it's negative 7 square root of 4. All right, so the square root of 4 is 2, so it's negative 7 times 2. Order of operations says you should do the radical first, and then negative 7 times 2 is negative 14. So f plus g of 4 equals negative 14. Questions on part A? All right, let's look at part B. Let f of x equal 3x squared minus 2 and g of x equal 2x plus 5. Find f plus g of x and state the domain, then evaluate the sum when x equals 2. So f plus g of x is equal to f of x, which is 3x squared minus 2, plus g of x, which is 2x plus 5. Anytime you add or subtract, you're going to combine like terms. So 3x squared, there's no like term, so you just bring that down. Plus 2x, no like term for the 2x. But negative 2 plus 5 is positive 3. So 3x squared plus 2x plus 3. So f plus g of x is equal to 3x squared plus 2x plus 3. All right, next we got to find the domain. So for the domain, we need to graph it and check and see how far to the left and how far to the right my graph will go. So if I go back to y equals, I'm going to clear my old equation and I'm going to plug in my new one. So 3x squared plus 2x plus 3. And then we hit graph. All right, so slightly different shape for this one. You'll notice that my graph takes up the left side and the right side. And even though it's cut off by my screen, I know it's going to go forever and ever and ever to the left, and it's going to go forever and ever and ever to the right. So there's no restriction. I can have any x value that I want. It can take up the whole graph. So for that, we always say domain is all real numbers. All right, the last part, we have to evaluate the sum when x equals 2. So I'm going to go ahead and call on someone to help me out with this. How can I evaluate the sum when x equals 2? What do you have for me, Layla?
What did you say?
How do I evaluate the sum when x equals 2?
You bring it down?
Like for the first example, what did I do when I had to find the sum when x equals 4? What did we do with the 4?
I don't know. I wasn't paying attention.
Okay, appreciate the honesty at least. We have to plug it in. Does that make sense, Layla? Layla, did that make sense? Where did she go? I couldn't even hear her. I don't think you're unmuted, Layla. So you have to take the 2 and you have to plug it in everywhere you see an x. So it's going to be f plus g of 2. So everywhere you see an x, you're going to plug in 2. So Layla, can you tell me what my equation is going to be when I plug in those 2's? Did we lose Layla? I think we officially lost her. Bye, Layla. See you later. So we've got 3 parentheses 2 squared plus 2 times 2 plus 3. And you're going to put that in your calculator. So we've got 3 parentheses 2 squared plus 2 parentheses 2 plus 3. And that's going to give you 19. So f plus g of 2 equals 19. Any questions on part B? All right, does anyone need more time before we flip the page? All right, let's go on to the next one. So there's 2 typos that I need you to correct before we get started. So let f of x equals 3x cubed minus 2x squared plus 5, and g of x equal x cubed minus 3x squared plus 4x minus 2. right here it should say find f minus g of x and state the domain. Then evaluate the difference when x equals -2. All right, so first thing we got to subtract the 2. So we've got f minus g of x. So you're going to take f, which is 3x cubed minus 2x squared plus 5 minus g of x. But I'm going to put g of x in parentheses. So parentheses x cubed minus 3x squared plus 4x minus 2. And I'm going to tell you why. The reason why we want to put it in parentheses is because you have to subtract the entire g of x. And most commonly, students will just subtract the x cubed, and they'll forget about the rest of the equation, and they'll just keep the sign. But what you're saying is you're subtracting the x cubed, you're subtracting the 3x squared, you're subtracting the 4x, and you're subtracting the 2. So essentially, you're taking this negative, and you're distributing it to every single term inside of the parentheses. So when you rewrite it, distributing a negative is the same as just changing the sign of everything. So positive x cubed changes to negative x cubed, negative 3x squared changes to positive 3x squared, positive 4x changes to negative 4x, and negative 2 changes to positive 2. Any questions so far? All right, now we combine our like terms. So we've got 3x cubed minus x cubed. So that's 2x cubed. Then you've got negative 2x squared plus 3x squared. So that's positive x squared. Negative 4x doesn't have a like term, so it just stays as negative 4x. And then 5 plus 2 is 7. So 2x cubed plus x squared minus 4x plus 7. Any questions about how we got that? All right, now we got to find the domain. So I'm going to go ahead and put this in my graphing calculator, and then I'm going to call on someone to help me find the domain. Where are all our friends going? Come back. All right, so we've got y equals, so clear that old equation and plug in the new one. So you've got 2x cubed plus x squared minus 4x plus 7. And then we're going to graph it. All right, I'm going to call on someone to help me out with the domain. What's the domain for this graph? What's the domain for this graph? What do you think, Venus?
I don't know. Is it all real numbers?
I would agree with you. Can you explain why you said all real numbers, Venus?
Because it go on both sides and it will like last forever, I guess.
Yep, I couldn't have said it better myself. Good. So domain is all real numbers. Good job. All right. Next, we have to find or evaluate the difference when x equals -2. How can I find the difference when x equals -2? What do you think, Sandra?
Don't you plug back in for all the x's?
What are we plugging in, Sandra?
Is it -2?
Yep, good job. So it's f minus g of -2. So everywhere you see an x, you're going to plug in -2. So make sure you put them in parentheses, especially because it's a negative. So it's 2 times -2 cubed plus -2 squared minus 4 times -2 plus 7. So we've got 2 parentheses, -2 cubed plus -2 squared minus 4 times -2 plus 7. And that equals 3. So f minus g of 3 equals, oh, I did that last class too, of -2, excuse me, is equal to 3. Any questions about that one? All right, let's look at example 3. Let f of x equal x squared and g of x equal square root of x. Find f times g of x and state the domain. Then evaluate the product when x equals 9. So we're going to multiply f times g of x. So that's x squared times square root of x. But you can't multiply an exponent with a radical. You can't multiply them together, so you have to change the radical to an exponent. So remember we did that last week. So to do that, you're going to find the exponent of x. If you don't see an exponent, you know it's going to be a 1. So it's x, and then it's going to be a fraction exponent. This 1 goes in the numerator, and the index goes in the denominator. What's the index of this radical? What's the index of this radical? What do you think, Karen?
2.
2. So 2 goes in the denominator. So it's x squared times x to the 1/2. All right. So now we have 2 terms multiplied together. We have the same base. When we multiply the same base together, we keep the base and we add the exponent. So 2 plus 1/2. 2 plus 1/2. You can change 2 to a fraction by putting it over 1. And then you need to have the same denominator. So both 1 and 2, the smallest number that they both go into is 2. So you can change this denominator to 2 by multiplying by 2. So 2 times 2 is 4. 2 times 1 is 2. So now we have the same denominator, so we can keep the denominator of 2 and then add the numerator. So 4 plus 1 is 5. So this is going to become fg of x is equal to 5 over 2. Oh wait, not 5 over 2. I lied. X to the 5 over 2. Let me get my white out to read it. Sorry guys, it's Friday brain today. All right, let's go ahead and find the domain. So to find the domain, I'm going to need to use my graphing calculator. So go to y equals, clear out your old stuff, and you're going to type in x raised to the power, put parentheses, 5 divided by 2, close your parentheses, and then graph it. So there's your graph. All right, what's the domain? What's the domain? What do you think, Ethan?
All real numbers.
So it can't be all real numbers, Ethan, because you see how my graph doesn't cross into the left side? There's no graph over here.
Oh, yeah.
So my x can only be what values? Positive x values or negative x values?
Positive.
Positive. So do you remember how we say that?
No, not really.
Remember, to say that you can only have positive x values, if x is greater than or equal to 0. That make sense?
All right. Yeah.
All right, lastly, we got to find the product when x equals 9. So you're going to plug in 9 for x. So it's going to be 9 raised to the power of 5 over 2. So you're going to do parentheses 9 raised to the power, put parentheses around the 5 divided by 2 as well when you put it in your calculator. So that's equal to 243. Oh, this is supposed to be a 9. You guys, my brain today is just not working. Any questions about example 3? All right, the last example, let f of x equal 6x and g of x equal x to the 3/4. Find f over g of x and state the domain. Then evaluate the quotient when x equals 16. So f over g of x means we have to divide the two functions. So f of x goes at the top, 6x goes at the top, x to the 3/4 goes at the bottom. Anytime you have the same base, so x and you're dividing, you subtract the exponent. So if I don't see an exponent for x, I can assume that it's 1. So it's going to be 6, keep the coefficient, x to the 1 minus 3 over 4. So subtract 1 minus 3 over 4. You can change the 1 to a fraction by putting it over 1. And then look for the smallest number that both 1 and 4 go into. So the smallest number that they both go into is 4. So you can multiply the numerator and the denominator by 4. 4 times 1 is 4. 4 times 1 is 4, so 4 over 4 minus 3 over 4. Now that we have the same denominator, keep the denominator. 4 minus 3 is 1. So your new exponent is x to the 1/4. So f over g of x is equal to 6x to the 1/4. Any questions so far? All right, then evaluate the quotient when x equals 6, or actually before we do that, we have to find the domain. So we're gonna go to y equals, and then you're gonna type in your new function. So 6x raised to the 1 divided by 4, and then we graph it. And you'll notice my graph only goes on the right side of my coordinate plane, so I can't have any negative numbers. So just like the last problem, domain is x is greater than or equal to 0. And then to evaluate when x equals 16, you just plug in 16. So everywhere you see an x, you're going to type or plug in 16. So it's 6 times 16 to the 1/4. So 6 times 16 raised to the 1/4. And that gives you 12. So f of g of 12, oh, let's do it again, of 16 equals 12. Any questions about example 4? Does anyone still need to see this before I change the screen? All right, let's go over your homework for tonight then. You have the homework from last night, which was 5.4 part 3 assignment. That's going to be due tonight at 11:59. And then your new assignment is 5.5, and that's going to be due Monday at 11:59. Any questions about that? All right, I'm going to stick around till the end of the period if you want to get started on your homework or if you have any questions. If not, I will see you on Monday. Have a good weekend.